Alright, hello everyone, this is Mr. Crocher. I wanted to give you help on problem 7. We are given this function right here, which is v of t is t to the third minus 10t squared and all the way down. And we're asked to find two different things, the displacement and the distance over this interval from 1 to 7. Well, the first thing to do is get a good view of the graph. So if you go to your calculator and you hit y equals, enter this function in here as the first equation. Good window is from 0 to 8 because it's graphed right here, but we're talking about the interval from 1 to 7. So if we go from 0 to 8, we'll get a good picture of it. And I just went from negative 10 to 10 to start off with. And if you graph it, it is right there, and there's a good view of it right here. And what you see about this graph, if you're looking from interval from 1 to 7, parts of it are above, and I colored those in green, and parts of it are below in red. And what happens is these are positive values, these are negative values, and positive values and negative values, and they cancel each other out. So let's go ahead and find the displacement. And what the displacement means is simply from 1 to 7 of our function. Where are you at? So where are you at if you drive? Well, let's see here. Where are you going to be at if you start here and you drive forward for a while, then you stop and you drive backwards for a while, then you drive forwards for a while? Well, if you look at this, these two areas are about the same. So you're probably going to be in the exact same spot where you started. Well, you can use your calculator to figure that out today. If you go to the math integration button, you can just go ahead and use your calculator. We're going to save some work today. And another way we're going to save some work is instead of typing this all out, if I hit the variable button right here, if I hit the variable button right there, I can go ahead and just put that whole function in there. So there's that function dx, and it's going to integrate from 1 to 7. It's going to put the positives and negatives together, and look what it comes out with. This number in scientific notation would be, let's see here, 4.8 times 10 to the negative 13. Well, wow, look at that number. That number 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros and 48. Well, I'm going to say that number is very close to 0 because your calculator just does this by estimation, not by doing the math. You could take this and integrate it, and you'll come up with 0. However, we're going to save time and use a calculator. So the displacement here is 0, and doesn't that make sense? You drive forward for a while, then you drive backwards for a while, then you drive forwards for a while, and everything cancels out, and you're back to the same spot where you started. You didn't travel any distance. Now, well, sorry, there wasn't a change in your distance. However, you did travel a lot of distance. You traveled all of this and all of this and all of this, just sometimes it was forward and sometimes it was backwards. So, displacement means overall change. It really wasn't a change in your location because you ended up where you started. Distance means what we have to do is take this value right here, which I'm going to write as the integral from 1 to 3 of our function, right? There's that distance from there, but we need to add it to this distance right here, which is the integral from 3 to 6 of vt dt. However, what's going to be the problem? This one and this one are going to be opposites, and these are going to cancel those out, and we don't want them to. So we're going to have to take the absolute value of this value right here. Whatever we get, we want to make it positive. And then what we want to do is integrate from 6 to 7 of this last spot right here, and it's already positive. So we have this value, which is going to give us this distance right here, and this integral from 3 to 6, which is going to give us this distance right here. However, it's going to be negative, but if we're looking for total distance, we don't want it negative, so we're going to take the absolute value. And here, from 6 to 7, it's positive, so that one's okay. So it is this plus this absolute value plus this equals total distance. give you the answer here is 63 halves, but you're going to want to find the fraction. So use your calculator again to do this. And once you have it here, right, it's going to be very simple. Let's go ahead and I'll do one. Let's go ahead and I'll do this middle one right here for us. Let's say if we want to integrate this function just from 3 to 6. Well, it's a negative 15, right? But it is absolute value of a negative 15.7. So it just counted as 15.7. And again, what you're trying to do is find these three parts together. And the parts where they cross right here, you can find those just by using your calculator today. You can graph it. Here's a graph again. And you can zoom in and say, well, it crosses at 1 and 3 and 6. So use your calculator to find those. We'll use different methods later, but today we'll save some work. You can find the points here, and you can find, or you can use your calculator to do the different integrals for you. Another thing on your calculator you may not know, but if you're trying to do fractions, let's say you want to do 3/7 plus 1/2. Well, it comes up to that nasty decimal right there, but if you hit the math button, you can make your calculator change it into a fraction for you, and you'll have the fraction 13/14. So when you're adding up the fractions, just remember to go math, fraction, and it'll put it as a fraction for you. Alright, I hope this helps. Again, the work's the same. The only difference is we're going to, when we talk about displacement, we just want one whole integral, puts the positives and negatives together, balances it out. But when we're talking total distance right here, we have three separate parts, and they refer to the three separate regions here. And one thing you'll notice in the book is sometimes they just go ahead and tell you to take the absolute value of all of them. Now, you really don't need to on the positive ones, but just to be safe, you can put them in there. Alright, hope this helps. If you have any questions, please email.